Okay guys, what we have here in this controller box that I made comes from quite a few years of messing with the wind turbines and trying different stuff, meter systems, dump load controllers. And what I found that most people do is their systems end up being this conglomerate of wire on the wall with no fuses, nothing in boxes, and that can create a lot of issues. Most of the time it doesn't, but at the least it's nice to have a nice neat system all contained in a box, ready to go and easy to maintain as well as reconfigured if you're savvy enough to do that. So what I did was I bought a metal enclosure box. It's just a regular junction box from Electrical Supply House, and it's 12 inches by 12 inches. And what I did was I put all the hinges on and made it into a box that has a door on it that can open and close. Alright, because these Hoffman boxes that you buy with hinges on them are in the hundreds of dollar range, and it's ridiculous to pay that much for a box with a hinge on it when you can do it yourself. These hinges were $2, I think, $1 a piece at Home Depot. Okay, so that makes up my box, which works awesome. And you can put the screws back in up here to lock it down. Alright, there's 4 screw holes. So that's the box I'm using. The components in the box are all needed to make this thing function right. A lot of people might say, well, you don't need this, you don't need that. But this is everything that you would need to make your system function. What this system does is it reads DC voltage, reads AC voltage, and has a couple other bells and whistles in here that are safety features. So basically it's for, you can use this system for a dump load controller for your wind turbine. You can use it to switch 2 different grid tied inverters. So say you want to use a 10 to 30 in low wind and a 22 to 60 in high wind. This system will allow you to do that, and you will have set point voltages that you can switch the inverters, or set point voltages of dumping a load from a battery or the grid tied inverters themselves. I know a lot of guys have been burning these grid tied inverters up, and one of the issues is that your dump load coil is usually either too small or too big, and it creates all kinds of havoc through the inverter. So what this box will do, it'll allow you to control that. And I have a special board that I designed and had somebody help me design and make, particularly for this system. And you can only get it through me because there's only one person that makes it, and that's my contact. And I'll show you that in a minute. But let's talk about what this thing does. Well, first of all, your DC voltage in. This is a nice little meter here. If you push the button here, it'll show you amps, power, which is watts, cumulative time, amp hours, and volts. And it'll do it on the bottom too, so you can look at volts and cumulative time, or amp hours, or you want to look at volts and watts, you can do that. Alright, so it'll read 2 at the same time. And this meter is extremely fast. When the power goes through it, it changes I think it's reads 5 times a second. So it reads all the incoming power on your DC. And then over here, this is an AC meter, and this will read all the watts coming in from your grid tied inverter, the China grid tied inverters, the ones like this. Okay, with the little dump loads on them. That's what that'll do. So what I did here was I put a lot of safety features in the system to make it all work and make it all in one box, so that your wires and all your stuff are not all over the wall. They're all contained in here. So all you need to do is either hook up a battery bank or a grid tied inverter in your turbine. So let's take a look at what we got. Well, first we have on the side here, I have a 15 amp AC fuse, which is very easy to, the fuse you can get anywhere at any hardware store, Home Depot. I also have a AC shutoff switch. So it's off right now, so if I turn it on, it'll turn on the AC power, and your watt meter will come up. And this watt meter can be shut off like that, or it can be turned on, and it shows volts, amps, kilowatt hours, watts, and your time, how long it's been running for in volts. So all this stuff is in real time. Okay. Over here we have a DC 60 amp breaker. All right. And we also have a brake switch. The brake switch is currently tied to the DC side of the system, not the AC side. I don't like doing that because it can screw up the phases In an accident, if you hit it while it's high winds, you have a very good chance of burning up your PMA and slamming it, slamming it down, slamming it to a stop. And when you do that, that's not good. So I did it on the DC side for this box. Over here we have an indicator light. The indicator light will come on when the relay inside is activated, whether you're dumping to a coil or if the relay is turning on and off another grid-tied inverter. Again, if you're using a 10 to 30 and you want to use a 22 to 60,000 watter and try to get low wind watts and low winds, and then it'll switch over to the other inverter and disconnect this one in a higher voltage, which will be created by a higher wind. So let's open up the box and see what we got. What I did with the box is I built all the components on a piece of metal back here, made one big board, and then bolted it to the box. So what we have here is we have an 80 amp rectifier. Down here we have our 12 volt connection. We have down in the back there a shunt which goes over to our DC meter. We also have our AC meter over here, and I put quick connects on them so you can disconnect the AC meter. You can pull this pin out to connect the DC meter, and if you want to work on stuff. Here's your relay. It's 60 amp car relay, and here's my control board. And what this control board does is this thing is very cool. This thing takes up to 100 volts DC, so it can read the turbine voltage up to 100 volts. And it's adjustable right here, right, the two screws right there. So you can turn them two screws and you can switch this relay at 12 volts whatever turbine voltage you want. So if you want to switch this thing at 55 volts to make it a dump controller, you can do that and not use the dump controllers on the grid-tied inverters, which everybody has having a problem with. So that's one way of using it. The other way of using it is you could tie a 10 to 30 volt inverter to this relay and have it switch off, let's say, at 13 volts. At 13 volts it would switch off, and then it would just allow power to be sent to the 22 to 60. So you have, you can adjust this thing from 0 to 100 volts. So any voltage range in between there, you can turn this relay on. This relay is normally open. This board works normally open, normally closed with this switch. So now it's normally open. Now we switch this. Now it's normally closed. Okay, and that means it's activated at that point. And if you look over here, it's activated. The little green light's on. Okay. This board needs a 12 volt constant power. So you will need to take some 12 volt from a battery bank. I recommend a 12 volt battery bank because if the grid should go down, you'll need 12 volts to work this system. I can install a 120 volt relay that will close when the grid goes down to send power to this. But for now, I have a 12 volt battery bank, so I just use the 12 volts off the battery bank to run this system. There's a couple different ways you can do it. And I make this box custom, so I can custom make these things for any situation. So that's the board. It has a little fuse in there, and what that fuse does is it protects the relay, the power going to the relay, so you don't fry the board. And if you look in there, you'll see a little red hookup. You can't see the black, but that's where you put your voltmeter. And you turn them two little screws. And the voltmeter, as you turn the screws, you'll be able to figure out what voltage you're setting your trip point at. And it's 1/10 scale, so it's basically 0.1 is 10 volts. Okay, 0.2 is 20 volts, and so on and so forth. All right, so that's the control board I had developed and made. Now, inside the box, you have your 12 volt hookup. So that's where your 12 volt will go from your battery bank or a plug-in transformer down to 12 volts. And from there, we have two main DC connection points. And there's your negative and positive. So you can hook your batteries to that. You can hook your grid-tied inverters to the negative and positive there. All right. So you can have a 22 volt inverter hooked here, and you could have a 10 to 30 volt hooked here, and this would turn off and disconnect the 10 to 30 volt while the 22 to 60 is still operating. And you could even do this with batteries too. Let's say your battery voltage, you want this thing to click on at 13 volts and send power to the grid because your battery bank's already full. You can do that. You can hook up a grid-tied inverter, and This you set your settings here for whatever, 13 volts, 12 volts, 14 volts. It'll turn on the GTI, grid-tied inverter, at that setting point. So there's multiple uses for this box. You have a 60 amp DC rated breaker over here. You also have a 5 amp fuse back in here for the 12 volt to protect the board and the components running through it. So it's a real nice board. And it's all enclosed, so basically all you do is punch a hole in it for your wires, your grid-tied inverter, your turbine, or your batteries, hang it on the wall, and bring your 120 in, and you're done. I can make this straight for DC, I can make it all for AC, but it's a real nice controller. I'm going to make a couple more of them for my own system, and I think that's going to be it. And get all the crap off the wall and just have the inverters there, and it'll be a nice, neat system. And you can track all the data with the meters that come with it. And over here, there's a plug. You plug your grid ties in, and you can just add a 3-way to that. And all that power from your turbine on the AC side will read right through this meter. So you'll actually see AC and DC coming in. Okay? Which is really cool. So that's about it. I just wanted to show it, and I'll come out with another video showing this thing in the real world. I'm going to try to get this up this weekend and do another video on it. So just give me your thoughts and let me know if you like it. Thanks for watching, guys.